Antibiotics were the wonder drugs of the 20th century. Now, amazingly, antibiotics are responsible for extending the average human life about 10 years. But we're currently in the middle of a global crisis where antibiotics are losing their effectiveness against infectious diseases. The headlines, if you could see them, are very alarming. Bacteria are rapidly becoming resistant to all of the antibiotics that we currently use. Now, in order to understand the nature of this problem, you have to understand bacteria. We live in a world filled with bacteria. Bacteria are everywhere. Everything that you look at, everything that you touch, everything that you put in your mouth, everything that you sit on is covered with millions and millions of bacteria. They are so small that you can't see them without a microscope, but they're there, and they are literally everywhere. You can find them at the bottom of the deepest part of the ocean. You can find them at the top of the tallest mountain. You can even find them in the polar ice caps. They can live in places where there is no sunlight, no oxygen, no food. They can grow in radioactive waste and in toxic chemicals and in boiling hot springs. When bacteria find a place where they can survive, they will multiply fast to very high numbers. Now, one of the places that bacteria like to call home is the human body. A recent survey by microbiologists identified over 10,000 different microbes that live on or in the human body. In fact, there are more bacterial cells in you than there are human cells. And there are more bacterial genes in you than human genes. So you could argue that each one of you is actually more bacterium than you are human. So, now that we've established that I'm talking to a room full of bacteria, I'm going to flatter the audience here a little bit and tell you that bacteria are amazing organisms. And one of the things that makes them so amazing is their ability to share genes with each other. Now, I need to describe this a little bit more because this lies at the heart of how bacteria become resistant to antibiotics. And I don't have any slides, so I will have to describe it to you. As you probably know, who you are lies in your genes. So for example, if you're tall or you have blue eyes, it's because you have genes that make you tall or that give you blue eyes. And likewise, bacteria that can live in Antarctica have genes that make them resistant to the cold. And bacteria that are not killed by penicillin have genes that make them resistant to penicillin. So where did these genes come from? Well, you're familiar with humans who are born with a set of genes that they inherit from their parents, and they keep the same genes until the day that they die. So for example, if you're born with brown eyes, even if you wish that you had blue eyes, your eyes will remain brown until the day that you die because these are the genes that you were born with. But this is not true for bacteria, who are in the habit of sharing genes with each other in some pretty incredible ways. And one of the ways that bacteria will share genes with each other is through picking genes up from their surroundings. And they usually do this after one of their neighbors has died. So we're going to refer to this technique as the funeral grab. Okay? Bacterium number 1 dies and releases its genes into its surroundings. And now bacterium number 2 will pick up some of these genes and pull them in. So now bacterium number 2 can do something that previously only bacterium number 1 could do. So this is the equivalent of you going to the funeral of someone who had blue eyes, taking a piece of their body out of the casket and eating it. And hey, you have blue eyes too. But now imagine that instead of blue eyes, you now are resistant to tetracycline. Another way that bacteria have to share genes is through viruses. So yes, bacteria get their version of the flu too, and there's a lot of viruses that will infect bacteria. So we're going to call this technique the viral pass. A virus will infect bacterium number 1 and pick up some of its genes, and then inject these genes into bacterium number 2. Now bacterium number 2 can do something that previously only bacterium number 1 could do. So this is the equivalent of you catching the flu from someone who has blue eyes. And after you catch the flu, your eyes turn blue too. But now imagine that instead of blue eyes, you're now resistant to methicillin. And a third way that bacteria share genes is through sex. So yes, bacteria have sex too, and they're actually pretty promiscuous. So we're going to refer to this technique as making whoopee. So bacterium number 1, the donor, builds a bridge to bacterium number 2, the recipient, through which genes are passed from the donor to the recipient, much like sexual activity that you're familiar with. But at the end of this sexual activity, bacterium number 2 can now do something that previously only bacterium number 1 could do before sex. So this is the equivalent of having sex with a blue-eyed partner, and then after sex, your eyes turn blue too. But now imagine, instead of blue eyes, now you're resistant to vancomycin. So you see, bacteria have lots of ways to share genes among each other. And with over 10,000 different types of bacteria in the human body alone, not to mention the millions of bacteria everywhere that you look, this is a huge community that is sharing antibiotic resistance genes with each other. So now in order to understand antibiotic resistance, you have to understand how antibiotics actually work. So in many ways, bacteria are very different than humans. And what this means is that they have a lot of components that can be targeted by specific chemicals. So antibiotics are fantastic drugs because they can kill a bacterium without harming a human by recognizing something very specific in the bacterium and not the human. They work like a key in a lock, very specifically finding and binding their target, which leads to an activation of the bacterium. But bacteria have evolved a number of different defensive maneuvers to avoid being killed by antibiotics. And so we're going to talk about 3 ways the bacteria can become resistant. And the first way we're going to call the upchuck. The antibiotic targets something specific inside the bacterial cell. But as soon as the antibiotic gets inside, the bacterium barfs it right back out, preventing it from finding its target. This is a technique that bacteria use to be resistant to tetracycline. Another way we're going to call the stealth mode. So the antibiotic recognizes something specific again in the bacterial cell. So the bacterium changes the target just enough so that the antibiotic no longer recognizes it. The target is in stealth mode, the antibiotic has no effect, and the bacterium is resistant. This is a technique that bacteria use to be resistant to streptomycin. And a third way we're going to call the ballistic missile defense. The bacterium makes a type of weapon that goes out and finds the antibiotic before the antibiotic can find its target. The bacterium sends out waves of these missiles that break down the antibiotic and allow the bacterium to survive. So this is a technique that bacteria actually use to be resistant to penicillin. So you can see that bacteria have lots of simple and effective ways to avoid being killed by antibiotics that include things like upchucks, stealth modes, and ballistic missiles. And the genes for these antibiotic resistance mechanisms are shared among bacteria through funeral grabs, viral passes, and making whoopee. So remember the important attributes of bacteria. They're small, they multiply fast, and they share genes. Your body is chock full of millions of good, innocent bacteria that cause you no harm. They live in a peaceful, gated community inside of you. But now let's imagine that some bad bugs move into this neighborhood and start causing trouble, being obnoxious, playing loud music, trashing the neighborhood. You feel sick, you go to the doctor, you get some antibiotics, and you take them. The antibiotics kill off most of the bad bugs and a lot of the good bugs as well. So now you're feeling better. So you stop taking the antibiotics before the doctor prescribed. So what happens next? Well, let's say that one of the good bacteria was already resistant. So when half of the neighborhood dies off from this antibiotic Armageddon, it multiplies fast to occupy all the empty houses. As in any war, in order to win, we need to develop new and more powerful weapons to fight and defeat them. And the time to invest in new antibiotics is now, before we're completely out of weapons. This needs to be a continuous, sustained effort, one that really should be considered a global health arms race. With funding support, new antibiotics can be developed continuously and released continuously into the market. As you can now appreciate, it is inevitable. Bacteria will eventually become resistant to the next antibiotic. But by this time, the next antibiotic will be ready. A sobering thought is that a number of people in this room are only here today because antibiotics saved your lives at some point in the past. We need to avoid returning to the pre-antibiotic era, where common bacterial infections resulting from things like a cut or a scratch or the strep throat could sometimes be a death sentence. In this manner, with new antibiotics, we can maintain the upper hand against the rise of the superbugs. Thank you.